Hello, everyone, and welcome to another Microsoft Reactor live stream today. Before we kickstart with this session, I just want to say a quick word about our code of conduct. After all, we are all here to learn, so I kindly ask you to be aware of each other and be open to all questions and viewpoints. And just be kind and considerate to everybody. Thank you so much. And yeah, let me bring our speakers today, Matthias and Magnus, coming from Gothenburg and Stockholm in Sweden. Hi, guys. Hello and welcome.
Hi, Erika.
Hello, Erika. Nice to be here again.
Yeah, it's nice to have you here again. So today we are kickstarting a new series, and we're going to get into GitHub for modern developers. You guys both work at Solidify, which is a DevOps GitHub consultancy in Sweden, but I let you introduce yourself because you probably do a better job doing that. I've known you for long, so I should know that better now. But yeah, please, I hand the word over to you guys.
Great. So let's see.
You want me to share your screen now?
Yeah, let's do that. That's perfect. So great. Hi, everyone, and welcome to this first session in the series. We'll come back to what it's about in a little bit. But since Erika started with the presentations, then yeah, let's do this slide first. And why don't you go ahead, Magnus?
Sure. Thanks, Matthias. My name is Magnus. I am Vice President and also consultant at Solidify, a Scandinavian DevOps/Azure/GitHub company. I am also a Microsoft Developer MVP, and today I'm going to do the moderating. I'm not going to talk that much and help out Matthias in the background. Over to you, Matthias.
Yeah, great. So I guess have a similar background as Magnus, also working with him at our company Solidify, and for us being Microsoft MVPs, this is super fun to get an opportunity to share what we've learned over the years. So
and we love MVPs.
Yay!
Thank you.
even if it's lunchtime, but yeah, that's perfect to eat and learn.
Indeed.
Great. So we're back with a new series, and this time we're going to step back a little bit and look forward at the same time. So we got some feedback last time that we talk about things that might not be clear to everyone. So we decided with Erika that why don't we talk about how to do modern development on the GitHub platform, but we start a little bit from the beginning again. So today I will talk about more developer-focused practices, and then we will be back during March to talk about requirement management, automation with GitHub Actions, and developer security. So we try to cover a lot of what's in the platform, but we'll do it from ground up this time. So hopefully, if you're new to GitHub, you will learn a lot. If you're already on GitHub, hopefully you will learn some of the latest features in there and practices. So, anything you wanted to add, Magnus?
No, I'm fine with this. Let's go on.
Great. So,
all right,
starting with that.
Stuff in the background now. So, yeah.
see you in a bit, Erika. Yep. We thought we'd start with asking ourselves, what is it actually that we want to talk about, and why don't we ask our modern oracle, right? So let's see what one of the AI tools can provide us as an answer. So how does GitHub help a modern developer? And maybe this is part of the future. Who knows that we will get more help from services like this AI tool. And I will talk a little bit about that later today as well. But here we see that the chat bot here gives me some insights. All right, I'll zoom in here a little bit. Okay, what are good practices for a modern developer on GitHub? Version control, collaboration, code hosting, of course, having a shared location for all your source code, continuous integration, and then GitHub has always been about community sharing, learning from each other, and so on. So yeah, thank you, OpenAI or ChatGPT. This sounds like a good definition. And I'll just see if I can get rid of the Teams chat here. That's something you should do as a presenter, that you do this ahead of time, right? So we'll see if I can just quickly end that process. 1 second. There we go. So okay, I think I agree with what the AI tells me, but let's see how we put this together. So it's actually quite close to what we thought about already. We have automation and some of the other ideas that the AI suggested in the other topics as well. But today we'll focus on the code hosting and version control bits to learn how to use GitHub as an individual. Then we'll talk about and look at how we collaborate as a team. We're also going to look at how we manage our development environments, because that's going to be an even more important capability in a platform to help us quickly collaborate with each other without interrupting our flow more than necessary. And then finally, we'll also touch on the AI part. It's hard to do a session these days without talking about artificial intelligence. So let's talk a little bit about how that can help us as developers in the future as well. And again, we'll be pretty hands-on in this series. So I'll share some conceptual ideas, and then we're going to look at how we apply it on the GitHub platform. So we're not going to do the big theoretical talk this time. We'll be a little bit more hands-on. But first, let's see what GitHub is about. So for those of you who haven't seen it before, it's kind of unlikely because it's more than 100 million developers using GitHub today. So it's probably so that most of you have already used GitHub in one way or the other. But you might not have used all the capabilities in the platform, because there are features for not just managing your code, but also manage your planning, automate your build and deployment, and automate other project tasks, and so on. And this is something we will cover in the series as well. It's we typically use the cloud version of GitHub, but you can run it on your own environments as well. So it's a very flexible setup in that sense. And the good thing with the cloud is that it is elastic. So the more power we need, we don't have to think so much about it. The platform will handle that for us, which I will show you in a bit is really powerful when it comes to, let's say, development environments. But let's start with GitHub as a developer. So when it comes to coding, you obviously need to learn a programming language or a development environment. But from the modern developer practices, it's should be common sense these days that you use version control. And if you're going to do version control, it's most likely that you will use the Git tool to do so. That's kind of the industry standards these days. And as we will see in a bit, GitHub will provide a hosting platform for Git. So you will still use Git locally on your development environment, but you will store your content on a central server in GitHub. And that gives you security, it gives you backups, and then, as we will learn, a great way to share work between friends and colleagues. We'll share a bunch of links at the end as well. So if you're new to Git as well, then follow one of the tutorials, and you should pick up Git fairly easily. But I'll show you how it's working as well in the first demo. I'll try to put together a short checklist of things that would be the most important practices from an individual perspective when it comes to maintaining your code in a good way. So we want to use a repository to store the content, and there are different approaches to do that, but we typically promote small repositories, so they are quick to work on. They're focused on specific things, but there's nothing preventing you from having what's called a mono repo and have all your assets, all your projects and code assets stored in one repository. But we'll typically use a small repository. Then we want to be able to control what gets versioned, and Git has a special control file called gitignore, and we recommend using that so you don't end up storing files that shouldn't be version controlled, like intermediary files from a compiler or data sets that would be more appropriate to share somewhere else. Then we use two practices with Git to manage changes. We use commits, and we typically commit often, so we get like a time machine where we can revert to earlier states by moving back and forth in the history. So that's a great way to manage change. And if you commit often, then you know they always have a good point where things worked. So if you're ended up going in the wrong direction, then you can just cancel out of that work, go back to the snapshot you had earlier, and continue work from that point in time. So we will commit often. Then if we're working with others, or for that matter, if we're doing different things at the same time, we shouldn't do that in one one and the same place. So in order to manage concurrent work, we use branches. So that's like a way to branch off and store files for one content under one name, and then I can switch back and forth between different branches if I'm doing things in parallel. So for instance, I might be doing new feature development and then I need to help with a bug fix. Then I can stash my work in my feature branch, switch to my bug fix branch, do the bug fix, push that, commit and push that, and then switch back to my feature development. And I don't have to worry about messing things up. And all of that are traits of the Git tool in itself. When we start using GitHub, we get additional nice web-based features like a good search engine. We have a good editor experience and so on. So let me move over to GitHub and let's create a new repository. So today we're going to work out of the Solidify demo account. So this is where we host our source code. This is a public organization, and then we can choose whether the repositories are public or private. And I will create a new one here. And then I will call this one Reactor. Yeah, what should we go for? Modern development with GitHub. I can give it a description. I can make it public. So if you want to check out what we're doing, you can use that URL that you will see in a bit. And then we can start with a README file, so we get the basic content in our repository, and then we create it. So this is doing an initialization essentially of a Git repository on the server side. So now this is stored on the server. If I want to work on this locally, then I can go to code and I can use either of the different options to clone the code back to my local machine. So I should be able to do that if I just click on this link, and then I will open a command prompt like this, and then do git clone, git clone, and paste the URL. And if that worked, I will have a new folder called Reactor Modern Development for GitHub, and I can jump into this folder and let's say open up Visual Studio Code to edit files in the repository. So now I'm in VS Code. I will trust this folder. That's fine. The only thing we got from the server was the README file. So this is what I have. And let's say I want to create a small .NET application. Then I can open up a terminal in VS Code, and once it wakes up, I can run a .NET command. Let's say I want to do a new web, and we can generate it like this, and it will create a small project for me, just a simple hello world type of application. So it added a few files for me, just like this. And then I talked about the Git commands. So now I will be able to do a Git status, and it will tell me things that I haven't done locally yet, like adding these files to version control and so on. But before I do that, I will check in my extension for Git in VS Code what files Visual Studio Code or Git has detected as possible files to commit. And here I can see that there's a bunch of different files. Some of these probably shouldn't be in version control. So like this NuGet cache file and whatnot. So I should add a git ignore file to specify what shouldn't be committed to my Git repository. And I can do this in multiple ways. I'll use the .NET command to generate a git ignore file. And this will generate a file based on the .NET settings. So if I look into to my commit list now, we see that it removed a bunch of files. So I'm not going to commit any files unnecessary. It also added this git ignore file. And if I take a look at that, here we see a list of all the folders and files that we are ignoring or not including in version control. So I can just keep adding to this one if I have specific file types that I don't want to share in my repository. All right, I'm good with this. Then I can create a commit. Maybe I call this initial code. I do commit. And then it tells me to sync the changes. So now if I want to make this available on the server, I need to also push it to the server. So if I refresh in the browser here, we will see that it's still not updating in GitHub. So I haven't created anything in GitHub yet. But if I do a sync or I click push, then it will take my local state and move it to the server. And this is interesting. You don't have permissions. What do you like? It's probably because I'm not properly logged in. So let me do a GitHub login. Oops. So I'll just do this, and I want to re-authenticate. I overwrite that, and I use my web browser. Then I get an authentication token. So this is just to cache my credentials locally, so it connects with the right GitHub account. So I'm going to do this like so, and I will also authorize. Fine. So now we're all set. And hopefully now, if I go back and try to sync the changes, it should go through. Fingers crossed. At least the message went away. So hopefully it worked. I'll go back to the GitHub browser, and now we see that we have all the changes here locally as well. And this is typically how we work. We do most of the work in our development environment. But if I would like to do something within GitHub, there are different ways to manage files here as well. So for instance, if I want to edit the README file, I can click on the pen over here, and then we can just jump into a text editor like this. A fairly new feature in GitHub is that I have a source tree to the left, and it's even in beta, so you might not have it already. Then you can opt in to try it out as well. So this is a new nice browser. As you see, I can make changes here as well. So I click on the pen, then I will be able to edit this file. Do something like this, commit the changes. It will be committed directly to the main branch as myself. I commit the changes. And now since I'm doing this on the server, it happens on the server automatically. So then the server is also connected with a web browser as the client in this case. If I go back to the main page, we can also see when the files have been changed. I click on commit here, for instance, then I can see the history of what has happened. And if I click on individual lines here, I will see the different commits. So the different changes here. So this one was created by the system when we created the repository. This one was created when I pushed the initial code. And here I apparently made a small change to the program CS file. If I'm interested in what change I made, I can click on the change, and then I will see all the files being edited, and I can see the before and after state in different views, depending on my preference. So that's typically how we use that. Another feature that could be useful in some cases is if I go back to this file here, then let's see. Oh, no, sorry. If I check one of the specific files, let's say the program CS, then I might be interested in, okay, who made the change to this? Why is it saying hello reactor? Then one way to get that information is to click on the blame, which is maybe a harsh word, but then I get to see when lines in the file were changed and by whom. So not so exciting this time since I made all the changes, but at least we can see that this line here was last changed by me in this commit over here. So then I get nice traceability to see what actually happened behind the scenes. So I think that's some of the good things to get familiar with in GitHub as an individual. Start learning how to jump back and forth between the web UI, the server, and the client. Fetch the code locally, edit it, sync, commit, and push. And then try out the different editing experience here. That's a great start to learn how to work with GitHub as a single developer. So next, I wanted to talk a little bit more about how we co-create in GitHub, how we actually start taking advantage of the real powers with this platform. So GitHub is great to do collaborative work, and it's been the home of most open source development for a long time. And 100 million developers on the platform says something for sure. And there is a trait of the tool that it is very open to collaboration. So we'll see some of it today. Next time we will talk about the issue system, and then we'll see more behaviors that really encourage you to engage with your colleagues, to share things, to co-create work, and so on. So there are a lot of tools to help us do that in a nice way. And from a sharing and working together perspective, we listed our top features that you should think about, or practices. And it's a lot of a combination of making it easy to come into a new repository, or come into a repository as a new developer, and being able to contribute. Then we also need to have some guardrails to do this in a controlled way. So we need to think about security, who we trust, as well as who should review changes by new developers. And there are mechanisms to do that. And lastly, we typically have agreements or assumptions on how we do things. some of those will be very good to enforce using policies. And we can do that at the code level to say that in order to change code in this repository, you need to do certain things. Like you need to do a code review. So someone checks the code before it's merged to a shared branch, for instance. And we typically handle that with what's called pull requests in GitHub. So to enable a good collaborative environment, start by adding a README file to the repository explaining how to contribute. If you're doing open source, we typically provide some additional files like a contribution file, a license file that documents how we work and how the intellectual properties in the repository can be reused. So it's both for contributing and consuming what's in a repository. From a security perspective, we should connect to an identity provider if we want to have, for instance, a single sign-on or multi-factor authentication. We can use what's called teams in GitHub to manage access and what you see. Then there's another control file that we can use called code owners, where we can specify code responsibility or who owns certain parts of the code base. And then when we use, let's say, pull requests to do a code review, then the code owner file can be used to automatically tag who should look at the code in the pull request. And we can also set up branch policies, like I mentioned. So let's go ahead and make a few of these, or try out a few of these things. So I think I had the README file here, and this is a good starting point. And if we, I mean, the best way to learn in GitHub is to browse through all the many repositories on GitHub. And I should actually show that in the beginning. So if I click on the GitHub logo at the top, you see things here, and you can click on explore repositories, for instance, and then you get a list of repositories that might match my interest. But you can of course also just search and look for different repositories based on whatever you want to to find. And if we look at one of these, I don't know, look at the NPM package management solution, for instance, we will see that there's a bunch of these, and they typically have documentation that tells you how to get started, what the repository is about, how to contribute, and so on. And this was a very ambitious README file, and that can also be true, but it can be very simple depending on what you want to do. So typically, I would create something like this, something with an introduction, how to get started, how to build and test the thing in the repository, how to contribute. And I do this using the Markdown language. And I even have a preview here where I can look at how it, or check out how it looks before I commit this change to the repository. And next time we will look more into the Markdown language as well, but it's just giving you a hint of what it could look like. And I'm going to commit this directly to the main branch. And here we can see that now if I go back to the repository, it's already live now. So now we have a good instruction on how to get started. As you've seen, I am committing directly to the main branch, and we can use branches to handle concurrent work, and we should do that unless you have a very mature practice and have other ways to handle change and do some other abstract way of handling branching. But you should typically do that, because otherwise it's very likely that you will end up with inconsistent state in your main branch. So if you want to release an update, it might require a lot of testing to get to a stable state. So we avoid that by using branches. But right now it's not enforced. So as you see, I have been able to commit directly to the main branch, and that's not a super good practice. And the most common problem here is that you do this, you end up committing to the main branch more by accident because you forgot to create a feature branch. So to prevent that accidental mishap, then I can go to settings and I can go to the branches menu here, and I can define a branch protection rule. And I have a lot of different things that I can set up here. But I will want to protect the main branch to begin with. And you can specify obviously other branches here as well, depending on your strategy. Today, I want to require someone to do a code review, to use the pull request in order to make a change. And then I want to require approvals. And then we can specify the number of approvals. If I had the code owner's file, I can require a review by someone in the code owner's file. I'll skip that now because we have a lot of things to cover today, but this is something we could include. I don't want to be able to or I can specify if someone should be allowed to bypass the rules. I can also specify if I want to run automation, and this is something we will come back to, but later in the series. So typically this is used to run some kind of continuous integration build to verify that the code change that we're about to merge is valid. So we will come back to that. And then, yeah, a lot of different settings here. So today, I think we'll be satisfied by doing this. And I think this is also, in general, a good setting here to say that I don't allow bypassing the above settings at all, not even allowing administrators to do so. So that depends on how you manage security. But if you have many administrators, then you might need to use this on certain branches just to prevent people from accidentally checking in code to the specific branch. So with that, I will make a small change and we'll see how this works. So actually I'll just go in and continue on the path to make very small changes. I'll show you one more editing option as well, since I'm in the editor. So I can click on the pen to edit this individual file. I can also hit question mark, and then I can see all the shortcuts, keyboard shortcuts I can use in the web editor or in the web view in GitHub. In this case, I wanted to open the GitHub dev editor just to show you what that looks like. So then I can hit dot, and I will be editing in a little bit richer experience. So it will look similar to VS Code, but it's not. It's just the front end. It's just an editor, not some tool that can run code. And we'll look more into that in a little bit. So once it's loaded, I can open up the file, and to make a change to this, then I wanted to create a new branch. So I will create a new branch. I call it feature new message, like this. And then I will switch to the branch. So VS Code is helping me to do this. Now it's apparently reloading some context, and not really sure what it did, but I'm doing all of this in the web browser still. So it looking like the local VS Code editor, but it's not. It's just the browser version of it. And for some reason, it's a little bit sluggish. All right, so there it worked. Okay, so now I just wanted to make another small change here to demonstrate the pull request workflow. So So now I'm making a change in this particular branch, and I will commit this to source control. I will update the message, and then I can, for that matter, I can create the pull request in this environment as well. But I'll choose to just push this to the server. See if I manage to do that. I think so. So I'll head over to the repository, and if I click bottom left, I can open up a context menu here where I can go to the repository again. And if it worked, then we will see what we see now. So it worked, yay. I did manage to push something into a new branch, and GitHub will propose and assume that the next step is probably to open a code review session, to open a pull request. So I will click on this and I will do a pull request. I can open it up like this. A good practice is to include the reviewer to begin with, and I'm thinking maybe Magnus want to review this. He's good at helping me with the reviews in this part of the code base. So I'm assigning it to him. Then I'm creating the pull request, and here we see that it's starting a thread of events that describes what has been checked in the code as part of the reviewer workflow. And I can check what has been committed, all the different individual steps that we have done to make changes, and I can see also the individual changes. And maybe if you're able, Magnus, you could perhaps review this file for me. Let's see if you manage to do that, because the interesting part here is that because of these policies, I can't finish the pull request until all the checks have been satisfied. So these are part of my policies. So in this case, I needed to do a code review by someone. So if Magnus has time, he can do that. Let's see if he is. Otherwise, that's the next step. You would go to the files, and then yeah. So now we actually got Magnus to help out here. So he worked on his side. He collaborated with me asynchronous. He looked at the content and approved it. And with that, I can now merge these changes back to the main branch. So that's something we see here as well, that this pull request is actually asking the system to pull changes from the feature branch into the main branch. And now when we have done the approvals, then if I click on merge, it will automatically do this for me. And I can just let it finish. And then the workflow here actually also suggests that I delete the branch. So these are good things that it keeps reminding me of what's good to do in the next step, so I don't forget about it, like cleaning up after me. So I should probably hit the delete branch. So I did that. And now if I go back to the code view here, I can see that we have the latest version here in the program CS file. So that has all been properly handled, and I can check the commit history here as well, and I can see that the last change was actually this merge from the feature branch. So all of that has been recorded in the history in GitHub as well. And there are lots of different things that you can do here that are super relevant as well, but we have a lot of other things that we wanted to show as well, so we'll focus on that this time. But again, go explore the collaboration features that I mentioned. Think about security and how to add code owner information and attach that to your processes as well. and we get a good way to work together asynchronously in a controlled fashion. But I wanted to continue on the story of how we can be really efficient in collaborating together. So with that, I wanted to talk about another feature in GitHub that's called Codespaces. And this is a fairly new feature, at least compared to the rest of GitHub. So this is a capability where GitHub can create on demand if I want to. Allows me to create a virtualized environment similar to what I would have when I'm working on my local machine. And this is super powerful because for one thing, it's very elastic. So I can create new code spaces pretty much when I need them. I can create very, very capable machines. So maybe I have a modest laptop for my day-to-day work, but I want to help out with, let's say, some machine learning experiments. And for that, I really would like to have a graphical processor to help me with the computations. Then Codespaces allows me to spin up a virtual environment with lots of capabilities. So it can be multiple CPUs, lots of memory, and even GPU-based hardware. So it's really, really powerful that way. But what's probably most valuable from my perspective is that it gives me a way to have an environment that is the same for everyone contributing to the repository. So I'm working on a Windows machine. Maybe Magnus is working on a Mac. We might have different versions of the .NET infrastructure. So in order to harmonize that, we can use Codespaces. And I'll show you what it's like in a second. But what we recommend to do is that we should look at what our development environment is about. Then we will generalize that in what's called a dev container. So there we can specify how a development environment is set up, which tools gets installed, how extensions in Visual Studio Code are configured, and so on. And then we use Codespaces whenever we want to have a fresh environment. And GitHub, for instance, switched to use Codespaces for developing GitHub. So all developers use Codespaces to contribute to the GitHub source code. And they went from taking it took about 45 minutes to clone the repository, get all the tools configured properly until you actually could start write some code, down to about 10 seconds when you create a code space that has all of those prerequisites configured already. And in order to do this so quickly, you need to cache things. So there's a component in Codespaces called pre-builds that allows us to pre-generate the virtual machine or the container actually that we are running in. So the initialization will be super fast. And then we can use this to accelerate inner sharing, to do code reviews, learn new things, and also collaborate. So there's a lot of good use cases for this. And for instance, code review, super interesting. If I want to help out with the code review, it shouldn't be a hassle to me to switch between different environments, maybe get disrupted in my own flow. With Codespaces, I can just open up a new code space and contribute directly. So I'm going to show you quickly what this looks like. So let's say I don't have .NET on my machine, but I want to help out developing on this project. Then if I go to code, instead of cloning everything locally, I can open up a code space. And if I just click on plus or create code space on main, it will create a default code space. But I'll show you some of the features here as well. So I can also specify where to run the code space. And then I can choose between all sorts of machines here, or at least a few. So maybe this one is similar to my Lenovo laptop then I would get about the same performance, but I can get beyond that as well if I'm ready to pay for it. So I'll be a little bit modest today. And the good thing here is that it's only costing me money when the Codespace is running, and it will automatically hibernate by default in 30 minutes. So if I spin something up and then forget about it, it will be hydrated, and then I'm just paying for storage, which is essentially nothing. But now it's starting up, and it looks very similar to the developer web editor that we had earlier. But this time it's actually connecting to a live environment. So if I manage to make this a little bit bigger, we see that we have the repository extensions and all that good stuff, but also something running live here. And this is running on an image that is called the default image, and it has a lot of tools installed already. So for instance, .NET is already installed. So if I want to run this program that we have created, I can actually do a .NET run like this, and it will build and run the application. This is a small web API application, so once it's up and running, it should start in a session, and I will be able to actually test it as well. So like the environment tells me, it's actually running the application on a port here already. If I'm clicking here, click on open in browser, it will open up a view for me that shows me the result of the running application. So in this case, it's hitting the public endpoint to this application, or not the public, the endpoint that we have defined in this application, the default route for this API. So it's returning this message. It's hosted on this Docker container, but the infrastructure in VS Code and Codespaces will proxy this to the outside world. So I am able to connect to it like this. So then with this magic URL, I'm actually able to share this with someone if I want someone to give me a quick test of what I'm doing before even I'm actually pushing it to the repository, maybe building and deploying it to a stage environment or whatnot. I can try this out with a colleague without actually making the change to the repository. So it's super quick to test some things out, and yeah, it's really, really great. But this is obviously also secure, or maybe not obviously, but it is secure. So by default, this port here is exposed only to myself, so it's private. But I can change visibility to make it private within the organization or public altogether. So yeah, that's options I have as well. And yeah, if I wanted to have a friend try it out, then I would share the URL like this. But it is really cool. It is live, so if I put in a breakpoint and do a refresh, then it should actually stop here in the middle of this line here as well. And I might not put the breakpoint at the right place, but hopefully you get the idea here. We talked about Codespaces in earlier sessions as well, so if you want to learn more, check those out as well. I'll leave it to this at the moment for you to explore all you can do in the Codespace. But the last thing I just wanted to show is that if you want to manage your Codespaces, you always have access to them at the top of the repository. So then I get a list of all my higher rated Codespaces like this. But I can also start a Codespace from a template. And this is really cool if I want to try something new. Maybe I want to try Jupyter notebooks and do some data analysis. Then I can create a Codespace from this template. I'm not going to show you anything of that, but it will also just work for you. It will create the default Codespace, but without the repository. But I get the sandbox to try out things very, very quickly. And if I like it, then I can obviously push that to a repository and continue over time in that code space as well. Great. So the last thing I wanted to just connect to what we talked about earlier. So these are what I talked about so far are essentially modern practices based on what we have done over the course of many years. So Git isn't new, GitHub isn't new. Many of the practices have been around for a long time. We're just improving the way we use them. The features have been improved over the time as well. So hopefully you see that it's a really slick flow. We stay in the flow if we continue, if you work like this. I can work in the browser when that makes sense. I can work locally when that makes sense. I can work in a code space, so I don't have to mess with development environments. But it's somewhat familiar type of work. So these days we're looking a little bit forward as well. What will happen next? And AI is an interesting component here. And in GitHub we have a feature called GitHub CoPilot. And this is what should we say, a AI pair programmer, maybe that's the best term, that helps me write code. So it's trained on code. So it's similar to the Chat GPT bot, but it's using a different model. So this one is called OpenAI Codex, and it's been trained on a lot of source code. So this is a feature that's available both to individuals and businesses in GitHub. And once we activate it and install the extension in VS Code, for instance, it will start pair programming with me. And this is really, really cool because it takes the good flow that we hopefully have already with Git and GitHub and gives me a boost on productivity. And the ones that have been working with this, they say that it really focus on flow. So it helps me to stay in my flow. If I'm thinking about how should I do things next, usually I would go to Stack Overflow or look on the internet on solutions. With Copilot, I can get that type of help in line in my development environment. So I'm more likely to complete tasks if I'm using AI-assisted development tools. And I'll show you as a wrap up a couple of small demos here, but we can use it to generate code. We can automate repetitive tasks, but we can also use it to learn new things. So I know we're almost out of time, so I'll be super quick here. And I have a Copilot space here, and I just want to do a new project in Node. And I'm by no means a good Node programmer, so that's where I'm thinking Copilot can help me. I mostly do .NET development. So what I've done now is I just initialized a small workspace here to do some coding, and I'm creating a JavaScript file like this, index.js. And let's say I wanted to create something similar to what we did in .NET, a small web server. And finally, it actually created a JS file. In this environment, I have the Copilot extension installed. So it's, of course, super slow when you're running short on time, but Copilot is installed here. So if you want to do use Copilot, you need to have it enabled and sign an account. You have a subscription for Copilot. But with this, then I can start program. In this case, I don't have anything, and I wanted to show you the natural language model that it supports. So I can ask Copilot, or I can just ask myself what I want to do. So I want to create a web server. So create web API to return hello world, like this. And if CoPilot kicks in properly, it should start suggesting things for me. So if this is what I want, then I will just say tab, and it will start adding code for me. So in this case, it's including an Express web server in my project. Then it's creating an instance of the application. I'm just hitting enter and tab, and it's even documenting the code, right? So it's pretty nice. And here we go. It's creating a route to say hello. If I browse to, in this case, port 3000, and I'm tabbing along. So that's essentially what I needed to do. So this looks like a proper web server. And if I go to new terminal, I should be able to say node and then run the index.js file like this. And it will fail because CoPilot didn't tell me to actually do an npm install of the Express package over here. So I'm just doing that quickly. But now if I once it's been downloaded, I go and run the JavaScript file here again. It should actually start the web server on this port. And if I go back to my browser here, I go to localhost 3000. There we go. So it helped me to do something like this.
So I think, Matthias, we are running out of time. And I think this is a very interesting topic, and I think we can probably go on for hours with just this topic.
All right, and I'll just show you one more thing, and then we'll wrap up. So I'm just creating another file here and say I want to create a calculator. And I have the idea that this is a calculator. So I probably know some of what it should do. So I start coding, and now we see that CoPilot is also kicking in. So maybe it thinks I would like to do a simple calculator. So then it's already suggesting a bunch of things that should go into this calculator. And I can just do tab and accept, and there I have my calculator. Last, I think I can show this as well. Maybe I want a list of largest cities in the world. If this works, it should. Now it got lost a little bit, but it will actually generate test data for me as well. But we should wrap up. But okay, so now the AI got confused. But yeah, I'll stop when I'm ahead. So a couple of examples, and we could definitely pick this up in a later session as well to talk about more things that you can do. But yeah, this is going to help us a lot to generate code from comments, automate repetitive tasks, because it's going to learn more from what we're actually doing in our environment as well. So it's super nice, but you need to understand the fundamentals. So everything we talked about up until now, super relevant. Then when you know the basics, that's where AI will really help you increase your productivity. So with that, this session was about modern development practices, and GitHub supports a lot. So it's top-notch, it should say, not notch code management. That kind of sounded weird. Top-notch code management, great collaboration tools. We have the Codespaces to help us work in the same way. We get good environments automatically. And then AI and CoPilot will improve the flow. We can share the link to this page. This is a really great summary on the GitHub features page where you get a good listing of all the collaborative coding capabilities. And we touched on many of them, but this is a good landing page. And we have the learning paths like we discussed that we would share. So definitely dive into this. And we'll do some Q&A, and of course, some of you might need to drop, but otherwise, we'll be back next week, right, Magnus, to talk about project
next week is me talking about requirement management with GitHub issues and projects and cool stuff you can do with Markdown.
Cool. All right, and I think you've been keeping on top of the questions, Magnus, so thanks for helping with that.
Yep. So thank you everyone for attending, and see you probably next week. Erika, any final words?
Yes, just thank you so much for being with us, both our online viewers and you, Matthias and Magnus. Block your calendars next week at 12 p.m. CET, the same time. We are going to be here, as well as the rest of the March, actually. Every lunch on Thursday, I'm going to be spending with you. I'll just drop it here once again. You can sign up for the whole event. I can't find it now, the whole series. Anyhow, but yeah, thank you so much for being here. I see you on Thursday, and have a nice day.
You too.
Bye.
Thank you. Bye-bye.